So often you have huge amounts of data, and you have to make some sense of it before you can draw conclusions. So we look for patterns or relationships between the variables in our search for some meaning. A well-tested conclusion about a pattern or a relationship in the data is called a law. A law doesn't explain the data, it summarizes the data, usually in the form of a relationship between variables that holds under specific conditions. A law is a little bit more, though, than just a summary of your own data. A law has to be independently verified many times. So a law generally has to be supported by decades of work before it will be called a law. The bar is really high, but like any conclusion, if new data doesn't support a law, the law has to be either refined or discarded. Now, here is how laws are made. Suppose you want to find a relationship between the volume of a fixed amount of gas and its temperature. Now, you know that heating a gas makes it expand, and that's true as long as the pressure isn't increasing at the same time. So we decide to measure the volume of a fixed amount of gas at several different temperatures, and we're going to hold the pressure constant. And we're going to keep the amount of gas fixed as well. Now, what we want to do is find a pattern in the data. Here's the data that we've collected. We have several different volumes in liters and several different temperatures, and we've kept the pressure and the amount of gas fixed. A good way to find a pattern in the data is to make a graph. Usually we put the variable that we have control over, temperature in this case, on the x-axis. That's the independent variable on the x-axis. The variable that changes in response, the dependent variable, goes on the y-axis. And in this case, it's the gas volume. Now, when we plot the data, we see a linear relationship. If we do it in Excel, we get a little equation for the line. Y equals 0.0821x, which tells us that you can calculate the liters of gas, the Y value, by multiplying the Kelvin temperature, the X value, by a constant, which happens to be 0.0821 in this case. Now, if we try this again with a different pressure or a different amount of gas, we still get a line, but that constant, 0.0821, changes. After many experiments, we can summarize the pattern that we've seen either as a statement, say, the volume V is proportional to the temperature at constant pressure with a fixed amount of gas, or we can do it mathematically as an equation. Notice this is much shorter. We can say volume V is proportional to temperature by saying volume is some constant times temperature. But what I'd like you to notice here is not all the detail, but the fact that we have multiple perspectives on a relationship between two variables, which was volume and temperature in this case. We've got the raw data. We've got a graph to visualize the patterns that are there. We have a statement that sums everything up in English. And we have a mathematical relationship that we can use to predict what the volume is going to be at different temperatures. Now, we also have an experimental design that we had to have for collecting the data. So that's 5 different perspectives on this problem. The more different perspectives you have on a problem, the better you can understand what's really going on. And this is why we do experiments. This is how science is done. We haven't explained anything, but we're in a good position to start looking for workable and testable explanations at this point.